So good afternoon, everyone. And this is lecture number 7. And since the class has been bifurcated, this is lecture number 7 for JEE. And as soon as I said this, the camera has gone off. That's not a good thing. I hope camera would be back. Anyways, let us not waste any more time and let us start on our campaign for today. In today's class, before getting on to today's class, I always told you whenever you come to the class, previous class, you must go and have a visit. What we were doing, I think we were into ray diagrams and things like that. Remember, no one is going to ask you to draw a ray diagram. I saw one question in JEE some 3 or 4 years back, probably, where they asked to draw a ray diagram. But normally, ray diagrams are not a question that will come, but still, you must know the basic rules because this is for your general knowledge. You must know the basic rules. So, as you can see, we had seen 3 rules: rule number 1, rule number 2, and rule number 3. Do we know all these 3 rules? Yes or no? With diagrams. We know these 3 rules of drawing ray diagram. Now, these are the 3 rules for mirrors. We also again will have to go through rules for drawing ray diagrams for lenses. So we'll go through these rules one by one. What is rule number 1? Can anyone tell me what is rule number 1 to draw a ray diagram for any mirror, whether it is a concave mirror or it is a convex mirror? Can you tell me what is the first? What is the first rule? Anyone? What is the first rule? Rule number 1. How can you draw? Remember, to draw a ray diagram, we'll have an object, we'll have a mirror, and then we'll have to find out using ray diagrams where its image is going to be formed. So basically, to do that, you will need at least 2 rays. How many rays you will need? You will need at least 2 rays. Those 2 rays will be reflected and they would be intersecting. Either they would be intersecting actually or they would be intersecting virtually. If they intersect actually, what type of image you will get if the reflected ray actually intersect or actually meet? We have discussed this already. What type of image you will get if the reflected rays actually meet? Tell me, my dear friends.
Real.
Real, that is clear. And if they do not actually meet, but they seem to meet, what type of image you will get?
Virtual.
Virtual. But to get any image, whether it is real or virtual, you will need at least 2 rays. So I'm going to tell you a set of rules. Out of these 3 or 4 rules, you can just draw 2 rays out of these 4 ways, and you will get an intersection point, and that will give you the position of the image. That is the first rule that we have to talk about, and we have already discussed this. You just need to draw the diagram. And what is this ray? The first ray, we have already discussed this. This is the incident ray going in green. This incident ray which is going along green is parallel to the principal axis. Yes or no? After reflection, this ray will pass through which point? The blue one.
Focus.
It will pass through the focus. That is the first ray that you can always draw. If a ray is parallel to the principal axis, if the ray is parallel to the principal axis after reflection, it will pass or appear to pass through the focus. It will pass through the focus in case of a concave mirror. As you can see, in case of a concave mirror, it is actually passing through the focus. In case of convex mirror, which is case number B, you can see that it is not actually passing through the focus. It is supposed to be coming from the focus if you trace the ray backwards. That is my rule number 1. Rule number 1 gives us the first ray that can be drawn. First ray that can be drawn to get ray number 1. And it is very simple. A ray of light which is parallel to the principal axis will always pass through the focus. We have seen that. Yes or no? Do we understand this?
Yes, sir.
You don't need to write this entire stuff. You just need to draw the diagram. Even you may skip the diagram because I think you would be knowing it from your past knowledge. Yes or no? You know this, Ray? Yes or no? We discussed this in the previous class when we discussed the definition of focus. Yes or no?
Yes, sir.
Remember, here again, two conditions should be fulfilled. The aperture of the mirror should be small and the rays must be parallaxial. Then only it will pass through the focus. Will you remember this? I told you now two conditions. In JEE Advanced, you might get a question where instead of parallaxial rays, they might give you marginal rays. Then remember, it is not going to actually pass through the focus. I will show you from where they will pass. Have you written this? Yes or no? Rule
No,
number one, you don't have to write rule number one. You just have to draw the diagram because no one is going to ask you what is rule number one. You just need to draw the diagram and understand that this is rule number one. Have you drawn it? I'll give you time to draw it. Have you drawn it?
yes, sir.
Okay. Now, once you know rule number one, you should be able to tell me, dear friends, what would be rule number two? Who is going to tell me what is rule number two?
Passing through focus will be parallel to the principal axis after reflection.
Well done. That is absolutely correct. So basically, it means that rule number two is going to be reverse of rule number one. You reverse the ray, you just change the direction. So now, my dear friends, my incident ray is passing through the focus. My incident ray is passing through the focus. If a ray is passing through the focus after reflection, it becomes parallel to the principal axis. This ray, this rule is reverse of rule number one. A ray, incident ray, which passes through the focus after reflection, it will become parallel to the principal axis. That will happen if your mirror is a concave mirror. The ray can actually pass through the focus, but in case of B, which is the convex mirror, the ray cannot pass to the focus. What will happen is it will appear to go towards the focus. It will appear to go towards the focus. It will not be able to go towards the focus after reflection from the mirror, but it will become parallel to the principal axis. That is my rule number two. A ray of light which passes through the focus or directed towards the focus after reflection will become parallel to the principal axis. How many of you knew this? Rule number two. Please raise hands. How many of you knew this rule number two? Are you all drawing the diagrams? Yes or no?
Yes, sir.
Remember, this chapter is all about remembering things. And as I told you, this year JEE Advanced ka paper was all about speed and accuracy. I've also released a detailed review of that paper, which I would also forward it to you so that you can understand what has happened in this year's paper, how many questions from which topic has come, physics, chemistry, or maths. Rule number two, a ray of light which passes through the focus or is directed towards the focus after reflection, my dear friends, would become parallel to the principal axis. I hope you have noted this down. Yes or no? No, yes.
No, sir.
Then you must be knowing rule number three. I am confident that my kids know rule number three. Can you now tell me what is rule number three, my dear friends? Rule
Ray
number three.
passing through center of curvature retraces its path.
Why does it retrace its path, my dear friend? Why does it retrace the path? The diagram is already there. It will retrace its path. Why will it retrace its path?
Angle of incidence is equal to 0.
Angle of incidence is equal to 0. That means it will strike the mirror perpendicularly. Do we understand this? It will strike the mirror perpendicularly and it will come back in the same path. We call it the ray of light is going to retrace its path. In case of concave mirror, the diagram will look like this. It will actually pass through the center of curvature, and after reflection it will again go through the center of curvature. But in case of convex mirrors, it cannot go to the center of curvature. It would be directed towards the center of curvature, and after reflection it will again seem to come from the center of curvature. These are the three rules. Out of these three rules, you can get three rays. You don't have to draw three rays. Out of these three, you can only take two. Take two rays. You draw those two rays. They will intersect. If they intersect actually, real image. If they intersect virtually, virtual image. And you will have your answers to where the image is going to be formed. This was rule number 3. Just for the sake of argument or understanding, I am going to give you the fourth rule as well. Now, this fourth rule is universal. It is always applicable. This fourth rule is universal. It is always applicable. Can anyone tell me what is the fourth rule? I don't know whether you know this rule or not. But this is a universal rule. It is applicable everywhere. And what does the rule say? Have you written down the third rule and drawn the diagram, bacha? The writing is not important, the diagram is important. And again, no one is going to ask you this in an examination hall. No one will ask you this question. What is rule number 1 for concave mirror? No. But you will have to understand it because we would be needing it probably to solve questions or sometimes just to understand how this image is formed. Have you noted it down, my dear friends?
No, sir.
Okay, sir. I will wait for you, sir. Simple diagrams just to make you understand the importance of ray diagrams, and then whatever I'm going to tell you, you are going to note them down, put star marks because questions based on this would directly come in your JEE main, and the application based question will be coming in JEE advanced. I'm waiting. Once you are done, please let me know the other class. I can't see your camera. Your camera has gone off. Can you just tell me whether you are there in the class and you are drawing the diagram for case number 3, rule number 3?
Yes, sir.
The, okay, that's the other center, I hope, which I can't see. I always keep on telling you that I'm omnipotent and omnipresent, but right now one of my eyes is not working. That is why I can't see the other class. I can see only one class. Have you noted it down, beta? Is it so difficult to note down?
Wait, sir.
Okay. Do you see the diagram clearly or do you want me to show you a bigger diagram? I can do that, not a problem. You can see this diagram or do you want me to show a bigger diagram? I can do that, not a problem.
Completed, sir.
Completed, sir. That takes me to rule number 4. And see, beta, for me it is important for you to understand how questions are going to come and not basically their answer. I'm not very concerned with the answer. I'm more concerned that you have understood the concept. What will be rule number 4? Maybe these 3 rules you have already heard. Maybe rule number 4 you have not heard, but rule number 4 is not anything different. It just tells us that angle of incidence is equal to angle of reflection. Do we know this? Yes or no? Angle of incidence is equal to angle of reflection. So whatever angle the ray is going to strike, the same angle the ray is going to turn back. Now remember that angle is with the normal. That angle is with the normal. So no matter how the ray or where the ray is striking, Whatever angle it strikes with the normal, the same angle it will strike or go away with the normal. But if you take the case of a particular point, if the ray is striking at the pole with an angle I, it will be reflected back by the same angle R. It will be reflected by the same angle at any position. But pole wala position becomes important because pole ke position pe if you draw the principal axis, if you draw the perpendicular is your principal axis, and therefore this diagram looks a lot better than what it would look if the ray would strike at some other point. Are you getting me this point, beta? Angle of incidence is always equal to angle of reflection wherever the ray strikes. But if it strikes the pole, the diagram looks like this. This is also one ray that you can draw if you want to draw. Make a ray, strike the pole of the mirror. Whatever angle it strikes, the same angle it will be returned back. It will be returned back on the same angle at any point. But pole wala point looks a lot better. Do we understand this? Can I have raised hand that we understand this? Again, I have shown you, I have told you 4 rules. You don't have to use 4. You only need 2 out of these 4 to get 2 rays, because once you get 2 rays, you can find out their point of intersection and you can find out the position of the image, and that is the most important thing that they are going to ask, where and when the image will be formed. We will come to that, where and when and what type of image will be formed. But before going on to that, let us introduce the most important concept of this chapter, and that would be coming on your screen as soon as you are done with this particular diagram. Do you understand this diagram? What is being said in this diagram?
Yes, sir.
It simply says I is equal to R and it is drawn at the point P. So it just looks a bit more symmetric, because if I do it at any other point, it will be striking at the angle and will be coming back at the same angle, but the normal would be somewhat slanted at any angle. So it will just look a bit different. Shall I move ahead in life?
Yes, sir.
The next thing and the most important concept of this chapter is the sign convention. Sign convention. Have you heard about the sign convention previously? Do you know about the sign convention, beta? Sign convention for mirrors or lenses or spherical surfaces or refracting surfaces. Do you know about the sign convention, beta?
Yes, sir.
Can you tell me what is the sign convention? Let us say this. Let us take the example of a plane mirror. Oh, why plane mirror? Because we are not dealing with plane mirrors anymore. So let us make it more. Let us make it more attractive and more general by making a concave mirror. Now, whatever we are doing for concave mirror is obviously valid for convex mirror. This is my concave mirror. Now, the most important point here is the pole P of the mirror. This is the pole P of the mirror. I hope everyone sees this point. Pole P of the mirror. Now, what is the first point that you must understand or remember here? Point number 1 for sign convention. I guess you know what is sign convention that we are talking about. This kind of sign convention is almost exactly similar to the sign convention that we did in chapter number 1, motion in 1D, and chapter number 2, motion in 2D. Do you remember that sign convention? We had a set of equation s is equal to ut plus half at square, v is equal to u plus at, and then we said that these equations must be used with proper sign convention. Do you remember what sign convention we used there?
Yes, sir.
What was the sign convention that we used? Anything along positive x was taken as positive, negative x was taken as negative, positive y was taken as positive, and negative y was taken as negative. Do you remember this? Sign convention for 1D motion. Do we remember this, beta? No?
Yes, sir.
Okay. Now see the sign convention for mirrors, and similarly we'll have sign convention for refracting surfaces as well. What is the first point in the sign convention? From where are we going to measure all the distances?
Pole.
Yes, that is the first point. All distances are measured from pole. All distances are measured from pole P as origin. I hope you know this. Yes or no? All distances are measured from the pole. Now, there's one more thing that you must remember. Whenever and wherever possible, the object is always placed on the left side. Yes or no? Do we remember this? Do we know this? Remember, this is how we draw the thing. Object is always in 99.9% of the cases, object is always on the left side. This is how questions are framed. I've hardly seen any question in which the object was kept on the right side. Right side or left side, it hardly matters whenever the object is placed, but normally object is placed on the left hand side. Now when the object is placed on the left hand side, this is how light travels. This is the direction of incident ray. Yes or no? Do we understand this? The blue arrow is the direction of incident ray. Yes or no?
Yes, sir.
This is the direction of incident ray or direction of light ray. The direction of light ray. Having said or talked about the direction of light ray, comes my point number 2. Can anyone tell me what is point number 2? It comes from the direction of light rays. It comes from the direction of light rays. What is point number 2, my dear friends?
Distances measured in the direction of incident ray are positive.
Yes, in the direction of incident ray, in the direction of ray, distances are taken as positive. Remember, distances are measured from the pole of the mirror. So, any distance which is like this from the pole on this side will be taken as positive. What about the other side?
Negative.
So any distance which is like this, the yellow one, this has to be negative. Am I clear with this concept? I'm not writing the negative one. I don't like talking about negatives in life, so I'll just write the positive one. The negative is the ulta of that. Do we understand this? Yes or no?
Yes, sir.
But that is only on one axis. What about up and down? Do we have a sign convention for up and down as well?
No, sir.
No, sir? Yes,
Yes,
sir.
sir. Yes.
Tell me, sir. What is the sign convention for up and down?
Plus y-axis positive, minus y-axis negative.
So all distances above principal axis, all distances above principal axis are taken as positive. Now I shall draw this. If the distance is like this, pink line, it is positive. If the distance is like this, it is negative. Do we understand this? Yes or no? No, yes. Can I have some raise hand that we understand this, sir? Yes. Now, what I'm going to do is I'm going to draw this jug. This becomes my minus y-axis and this becomes my plus y-axis. Then I'm going to draw this jug. This becomes my positive x and this becomes my negative x. So basically, if I just draw a smaller version of this entire thing, If I just draw a smaller version of this entire thing, if I just draw a smaller version of this entire thing, this is plus x, this is minus x, this is y, this is minus y, and this point is your p, and this point is your p. Anything along this direction is positive. Anything along this direction is negative. Anything along this direction is positive, and anything below this direction is negative. So now it starts to look like exactly the sign convention that we use in your motion in one dimension. Remember, here the object is on the left hand side. If the object was on the right hand side, the entire thing would have reversed, but that does not generally come. Do we understand this? Yes or no? No, yes. Can I have raised hand that we understand this? Okay, you'll have to draw this entire thing that I have drawn in the same way that it is drawn, and then I will show you a more cleaner diagram, because sometimes my diagram become, I do all the things in the diagram, so sometimes my diagram become a bit clumsy. I hope it has not become clumsy here. I show it here on the other more cleaner diagram. Please let me know if you are done. Everyone done? Yes or no? No, yes.
Yes, sir.
Then the same thing can be illustrated in this diagram. As you can see, this was the sign convention that I drew. This side is positive, this side is negative, this side is positive, and this side is negative. Now the same sign convention holds true whether you have a concave mirror, which is side number A on the left hand side, or whether you have a convex mirror, which is on the other side. Remember here, light, as you can see, is coming from the left hand side. Light here is coming from the left hand side. That means the object is placed on the left hand side. Do we see this, my dear friends? Do we see this, my dear friends? And I would expect you to draw this. You don't have to draw everything. You just understand the sign convention. The previous diagram was good enough. This is just taking things to another level. Now remember, whatever we do in optics, whenever we solve any question, all questions, all questions, all questions, we'll always have to use the sign convention. All question, always we will have to use sign convention. So you must understand what is positive, what is negative. If you have doubt in that, your answer will become irrelevant. Can I move ahead in life? Shall we move ahead? Have you drawn this?
No, sir.
Okay, draw this. You already drawn this. You have already, as I can understand, we have already drawn this part. The other part is nothing but, oh, it become a circle. Good. The other part is nothing but just they have shown that if there is a concave mirror, same. Whether it's a convex mirror, it is same. Doesn't change anything. Shall we move on?
Completed, sir.
Completed, sir. Here is a small question, sir. Small question, sir. If I mark this from here to here, what is this, beta? What is this known as?
Positive.
Array, what is this distance known as?
Focal length.
Focal length denoted by the legendary letter small f. Similarly, if I mark it here, it would be this distance would be the focal length f. All of us understand this focal length, yes or no? All of us understand this focal length, yes or no?
Yes, sir.
Now we have focal length of a concave lens, a concave mirror, and focal length of a convex mirror. Sign convention. We'll have to use them with sign convention. So now can you tell me, having understood the sign convention, what will be the sign of focal length for a concave mirror? What will be the sign of focal length for a convex mirror?
Concave negative, convex positive.
Well done. Concave mirror would be negative, and the reason is it will be measured from pole like this. It is in the opposite direction, and therefore it will be negative. What about the focal length of a convex mirror?
Positive.
It would be positive. The reason simply being it will be measured in this direction from the pole, and it will be in the direction of light rays, and hence it is always going to be treated as positive, whether you place it on the right hand side or left hand side or whatever side. Do we understand this? Placing the object right or left does not change the focal length of the mirror or the lens. Will you remember it?
Yes, sir.
Whether it's a mirror or a lens, it does not depend on where the object is placed to determine whether it is a concave mirror or a convex mirror. Sir, you place it on the left hand side, sir, it becomes a concave mirror. Sir, you place it on the right hand side, it becomes a convex mirror. No. Now in mirrors, you might not have that confusion, but in lenses, you might have. You might say, sir, if I place the object on the left, it will be a concave mirror. If I place the object on the right, it will be a convex mirror. No. A convex lens, no. A lens remains lens. Its type does not change just by shifting the object. Yeah, if you dip it in something, then it might become something else. Is it clear till here? Yes or no?
Yes, sir.
Then we move on to the next thing, and then after that, we'll move on to some lovely things. The next thing is important formulae that you must really remember. Important relations. Important relations. Important relations that we will be requiring in this chapter. What is the first important relation that you must remember in this chapter, my dear friends? Yes, my dear friends. What is the first? The first relation is F will be R by 2. F is R by 2. What do you mean by F and what do you mean by R?
Focal length is F. R is radius of curvature.
Yes. Focal length of the mirror is equal to the radius of curvature of the mirror. This is the point where parallel rays after reflection, they will meet. They will meet. Now remember, this equation is only valid when? Always valid? F is R by 2, always valid? Or is it valid in some only particular cases? And remember, you'll have to remember those cases because you may not encounter those cases in JEE Main, but you may encounter those cases in JEE Advanced. F is equal to R by 2. Is it valid everywhere?
For paraxial rays.
Yes. So remember that. It is only valid for parallaxial rays, and it is also valid when the aperture is small. Do you understand this? It is only valid when
For paraxial rays.
parallaxial rays and the aperture is small. Will you remember this? Please don't forget it. Now remember, this equation again has to be used with what? Without sign or with sign? Without sign convention or with sign convention? Remember, every relation that we write, this has to be used with proper sign convention. For a concave mirror, focal length is negative and therefore the radius of curvature also becomes negative. Do we understand this? Real science will give me more confidence. Do we understand this? Every equation should be used with proper sign. This equation should also be used with proper sign. What is equation number 2 that you must remember? And this is the
One
equation that everyone knows, which is the magical mirror formula. What is that mirror formula?
1 by V plus 1 by E equals to 1 by F.
1 by V, mirror formula, plus 1 by U
Equals to 1 by F.
is equal to 2 by R. That is the actual formula. That is the actual formula, my dear friends. But if you only talk about parallaxial rays, my dear friends, then this formula becomes what? 1 by V plus 1 by U becomes 1 by F. Will you remember this, my dear friends? This formula is only valid for parallaxial rays because F is equal to R by 2 is only valid for parallaxial rays. Do we understand this, my dear friends? Kids, bachoi.
Yes, sir.
Remember this formula. Again, remember all the terms in this formula has to be used with proper sign convention. Do we understand this? They have to be used with proper sign convention. Can I have raised hands from everyone that we understand this, sir? Without sign convention, we are not going to use anything because it will create a lot of trouble. A simple plus minus ka mistake will give your answers a completely different look and will start look very different. Now, this is the point where we understand some things that we are always going to remain true. So some in some cases we can understand what will be u, whether it will be positive or negative, where it will be where v will be positive or negative. Let us first talk about case number A, focal length of the mirror. F, focal length of the mirror for concave mirror. These are the important points. Will it be positive or negative?
Negative.
Negative. Well done. Point number B. I hope everyone is voting. Focal length for convex mirror.
Positive.
Well done. Keep on noting everything. All these points are golden dust, my dear friends. See, for real objects, u will be
Negative.
negative. Well done, my dear friends. That means for virtual objects,
Positive.
well done. For virtual objects, u would be negative. No, u would be positive. I hope everyone is noting it down. Yes or no? No, yes. Let us move one step ahead. E. For real objects, HO. Let us not write it real objects. For erect objects, Normally, erect object will be like this.
Positive.
Yes. HO means H standing for height, O for object. O is for object. I is for image. For invert,
Negative.
inverted object or image, HO. In that case, if the object is inverted, it will be negative. Okay. नहीं, E के बाद F आना चाहिए ना. For real images, let us talk about V. Real image, will it be formed which side?
Negative.
Yes. Well done. For virtual images,
Positive.
anyone has any doubts on this? Please come up. This is the time that you're going to come up, my dear friends. Everyone understands this? We are noting down as many things are possible because this chapter is all about remembering the stuff. The next stuff that we are going to understand is known as what? Magnification. Point number 3. Point number 3 is known as magnification. I hope you all understand what is magnification. Who is going to help me out in understanding what is the magnification, my dear friends?
Minus V by U.
Arey, tell me the definition first. What is magnification? Remember, I'm not concerned. My least concern is the correct answer. My only concern is the correct concept. What is magnification? And I have gotten a diagram for you. As you can see here, we have an object here. Do we see this? And HO is the height of the object. And what type of image is getting created? Is it real image or is it virtual image? What type of object is this? Is it a real object or is it a virtual object?
Real.
Well done. Is it an erect object or inverted object?
Correct.
Shabash. Well done. Let us talk about the image then. What type of image is this? This is the image.
Real.
Real. Is it inverted or is it erect?
Inverted.
So remember, whenever we have real image of a real object, it will always be inverted. What happens with virtual objects? We will see when virtual objects come. Someone asked me in first class when we are doing this plane mirror, sir, give an example of virtual object. Was it from your class or that class? Your class? C class, T class, which class? Someone asked me, sir, give an example of virtual object. I neglected that question. I avoided that question. Not because I don't know the answer, just because I did not want to bring it at that point in time. But that virtual object is very soon going to come. Going to come and haunt us. And it came in this year JEE Advanced. 4 questions there were lens or in the match the column type, and they were all on virtual objects. All questions were on virtual objects. So that virtual object is going to come right now. Okay, let us talk about everything else. What about U here? Depending on the sign convention, tell me whether U is positive or negative, so that we can recollect everything that we have done. U is positive or negative?
Negative.
Eh? Positive or negative? Negative. Yes or no? What about V here? Positive or negative? V is positive or negative?
Negative.
Well done. What about the focal length f? Positive or negative?
Negative.
Well done. This is a concave mirror and I have an image. Now, how do I define magnification? Now, we can have two types of magnification. We'll probably discuss the first type here. The first type here is known as transverse or lateral magnification. Transverse or lateral magnification. Whenever someone uses the term magnification, he is basically asking you this type of magnification, which is the transverse or the lateral magnification, denoted by the legendary letter small m. And how is this defined? Yes, now the question comes to you. What is the definition, my dear friends, of transverse or lateral magnification? Hmm? I've told you that before, beta. I always keep on telling you, beta, if you come to the class without going through what has happened in the previous class, all the good work has gone down the drain. If you think that you can sit here for 1 hour and become IITians all of a sudden, well, that is not going to happen. No magic wand I have got. I am no Dumbledore, and this is not Hogwarts, and you are not, definitely not Harry Potter's and Hermione's, that I could wand a magic wand, ooh, so, and create IITians out of you. Even Harry Potter and Hermione is there to do a lot of hard work to become Hermione's and Harry Potter's. Dumbledore did not create Harry Potter out of a hat. Yes, having said that, gone to the fictional world. Can you tell me what is the magnification? Transverse or lateral magnification? Say someone. Array, look at all. I have discussed almost everything apart from these two yellow gentlemen. So you have to go do something with this yellow gentleman here. Tell me, what is lateral or transverse magnification? Yes, I saw someone speaking something. Yes. Say. Array, say na. No one knows it. Shameful. T class, which is invisible class. Anyone knows? Array, say.
Sir,
Yes, sir.
size of image by size of object.
Not the exact word size. H stands not for size, but for
Height.
yes, height of the image. It was so simple, sir. This is height of the image divided by height of the object. That is how transverse or lateral magnification is defined. So it becomes HI divided by HO. And I hope that my Hermione's and my Harry Potters will remember this magic spell. They call it spell. This magic spell of finding out the magnification from height of the image and height of the object. Will you remember this? Yes or no?
Yes, sir.
And using simple. That's why the diagram is here. If you are using simple similar triangles, one triangle is the green triangle and the other triangle is the pink triangle. You can easily tell me, my dear friends, both are similar triangles. You can easily tell me HI by HO.
Sir,
Yes,
can you tell us what is the definition for magnification?
the definition is right there on your board. What do I tell? Height of the image divided by height of the object. That's it. That's the definition. Is there any problem with that, beta? Paka? Is it clear? That is the definition. This dabba is the definition of magnification. Do we get this? Beta? Do we understand this better?
Yes, sir.
What was the doubt? I could not get your doubt. Why? What doubt you are having, beta? This is the definition. This ratio is the definition. And remember, it's a ratio. So magnification is just a number. It will always be a number. So this is one quantity which is a number. Do you understand this? Can I move ahead, beta?
Yes, sir.
Okay. Now, from these two similar triangles, one is the pink one and other one is the green one, I can easily find out the relation M will be equal to HI by HO. That will be equal to minus V by U. Why minus? Because image is inverted, object is erect, and therefore this negative sign comes. This is the formula for the image, for the magnification created by a concave or convex mirror. The formula we have derived is for concave mirror, but this is valid for convex mirrors as well. Can I have some raise hands from everyone that we understand this? Okay. Now remember, beta, this formula, whatever formula we derive, it has to be used with proper what?
Sign convention.
Yes, my dear friends. Now we are talking proper sign convention, because if I don't use sign convention, things will go wayward. Now this is the original formula. Now this formula, as you can see, is given in terms of what I'm doing, in terms of V and U, or in terms of HI and HO. You can convert it from the mirror formula. You can find out the value of V by U, and you can convert this formula from V by U to F and V and F and U. I'll give you that shortcut formula, and then I will hope that you can remember that shortcut formula, because if you remember that shortcut formula, you will be saving a lot of time in the examination hall. If you don't remember that shortcut formula, you can always find the answer from this one. But again, to find the answer from this one, you will need to first find the value of V from the value of U, and then you can apply this formula. If you don't want to find the value of V first, you can straight away apply this formula, F upon F minus U. This formula is same as the formula that we had done. The only difference here is, instead of relation between V and U, it is given in terms of U and F. Similarly, I can write this in terms of V and F, and in terms of V and F, the formula looks like this. So all these are the one and the same things. All of this have been derived from the very first formula, and the very first formula is, as I said, the definition of magnification, and everything has been derived from this pink box. From the pink box comes the yellow box, from the similar triangle. From the yellow box, you can move on to the blue box. From one blue box, you can move on to the other blue box. Am I clear up till now? So far, so good.
Yes, sir.
Anyone having any doubt?
No, sir.
Okay. Just before going on to wind of this class, can you tell me If you have a real image of a real object, what would be the magnification? Will the magnification be positive or the magnification is going to be negative for a real image? Is the magnification positive? Is the magnification negative? It's right there in front of your eyes. Open them and see the vast universe behind you, besides you, above you, below you, forward of you. Yes, magnification beta.
Negative, sir.
Well done, and therefore I will take you to the point number H. FGH comes the next point. I for real image. Remember, we are talking about real objects and real image. The magnification M would be negative. For virtual image, magnification will be coming as positive. Do we understand this? Yes or no? No or yes?
Yes, sir.
For real image, magnification is going to be turning out to be negative. For virtual image, the magnification is going to turn out to be positive. Has everyone noted it?
Yes, sir.
Okay, then you can note down this small table as well. There is nothing that I need to explain in this table. It is quite evident. Have you noted down this magnification positive, magnification real and inverted for real and virtual images? Then comes this small thing. Point number 1, point number A, if the magnitude of magnification is greater than 1, we will call the image as enlarged. The height of the image will be more than the height of the object. Image is enlarged. Point number B, if the magnitude of the magnification, let us say it is -2, -2. The magnitude is more than 1, it will be enlarged. If the magnitude is less than 1, 0.5, minus 0.5, plus 0.5, we will call it as diminished. Do we understand this? Yes or no? If the magnitude is less than 1, we will call it diminished. If magnification is less than 0, the image is inverted. If the magnification is greater than 0, for example, this is -2. If this is -2, the image is inverted. If this is +2, it is erect. Do we understand this? Yes or no?
Yes, sir.
But if the magnification is -2, it will mean image is more, 2 times more, object is 2 times less. Do we understand this? Whether it is enlarged or diminished depends on what is the height of the image. If the height of the image is more, it is enlarged. If the height of the image is less, it is diminished. Do we understand this?
Yes, sir.
Well, then this brings us to an end of this class. In this class, we have taken some steps and move forward in life. We have seen the sign convention. We have seen the ray diagrams. In the next class, we'll go ahead with this magnification thing, and we will see also what types of images can be formed using a concave mirror and a convex mirror. And those are the things that you will have to remember so that you can answer some questions pretty quickly and solve some so-called difficult questions in the JEE Advanced. So I'll see you in the next class. Take care. Have a nice
Sir.
day. If any doubts, you can ask.